So this is factor completely. So we've been working on factoring for quite a few sections now. So factor completely. The first thing you want to do here, now that we're getting to kind of more, I guess you could call them a little bit more involved questions. Sorry, I don't like my plus sign there. Dang it, I did it again. Just marking up my board. But these are a little bit more involved as far as, you know, they have a little bit more going on with them. So the first thing you want to look at is, before you start doing this piece here, is say, is there anything that I can multiply or divide out of everything? You know, before I just start trying to factor this. So if I go 3, 30, and 72, well, all of these can divide by 3. Every single one of them can. 3 can divide by 3, and that would be 1. I don't need a 1. I don't need a 1 in front of here, but if you want to note that it's a 1, that's fine. 30 divided by 3 is 10. And then we also have 72. And this was a minus, and that's a 7. So 72 divided by 3, and we get 24. Okay, so it just brought it down a little bit, and I know that might look a little bit messy there, so you can always rewrite it. It's going to be x squared plus 10x minus 24. So if that helps kind of rewriting it there instead of just having the numbers up above. So this is what we actually want to factor now, is this piece here. So to get x and x, just like we did before, that's x squared, or x times x, right? Because that's what x squared stands for. And then to figure out the other pieces, we look at the last term, 24. In order to get negative 24, I'm going to have a negative times a positive. So I know I'm going to have one positive and one negative in here. And what that tells me is that once I find all my factors of 24, I'm looking for the factors that subtract to get to 10, not add. Okay, so let's go ahead and write down our factors here. We have 1 and 24, we have 2 and 14, 2 and 12, and 3 and 6, and 3 and 8, I'm just losing my mind, 4 and 6, there we go, got it now. So remember, we want them to subtract down to 10. Okay, well 2 and 12, if I subtract those, I get 10. And then I need to make sure that I put them in the correct spot here. Because if I just kind of throw them in here and say if I did it like this, well, it does subtract to get 10, but it's going to subtract to get negative 10. Because 12 is in the negative spot. So I want 12 to be in the positive side so that it's positive 12, negative 2, and I get positive 10 when I divide that away. So we just want to make sure we're paying attention to that, where we put our factors when we're in there. If they're both positive and they're both negative, then it's not as big a deal because that's a little bit easier. You know, we don't have to worry so much about where we put those ones. But when we have one negative, one positive, we do have to make sure we're putting them in the correct spot, because we'll get the correct number on the end, but we won't get the correct number in the middle. All right, let's keep moving here. Okay, so we're going to factor again. So this one doesn't look like, and I cross my Z's if you haven't watched these videos before, because my Z's and my 2's look pretty much the same. So students have told me that, and so I've started crossing my Z's so you can tell the difference between the two. So looking at this, it doesn't look like I can divide anything away from these. 3, 20, and 7, there's nothing that can divide into all three of those numbers. So I can just go ahead and get started here, and I know this is going to be my form. Again, I have a negative here on the end, so I know I'm going to have one positive and one negative. That's the only way that's going to work. And then for 3 and Z, I know it's going to be 3, Z, and Z, because it's 1 times 3. Those are my only options there. There is another method to do this, because this one, I'll show you this method. This is kind of the way I learned to do it way back, when I was in high school. But there is kind of a slightly easier way to do this. So I'll show you this way. And we have 3, and that's 1 and 3. And then we have 7, and that's 1 and 7. So these are very simple because there aren't multiple options here. It does start to get very complicated when there's multiple options. Really what we have to do is make sure we put them in the right order so that when we multiply them together, they add to get 20. So what I would want to do is I wouldn't want to put 3 and 1. I'd want to multiply 3 and 7 because that would give me 21. And then 1 times 1 would give me 1. So when I subtract these, I get 20. Okay, so again, this probably already looks a little bit complicated here because I have to make sure I match them up right. So if I want to multiply 3 and 7, I need to make sure they're not in the same parenthesis here. They need to be in opposite parentheses like this. And then 1 and 1, same thing with 1z and the 1. They need to be in the opposite parentheses, so those ones get multiplied. And what I'm noticing here is that it's going to end up being negative 21. So I kind of put this in a little early with the, oh, that's too much. Let me bring that guy down a little bit. So I put these negative and positives in here just a little too early because I want this to be negative and I want this to be positive. That way it's 7 times 3 gives me positive 21. Negative 1 times z gives me negative 1. So I end up with a positive 20 here. So this is factored. And understandably, this is a little bit more complicated. It might take a little bit more understanding for this one. So there's also this method that Alex likes to do. So I'm going to show you. It's kind of a cute method where you can actually multiply the beginning and the end. And you get one number. And then you break down the factors of that one number so that they either add or subtract to the middle. So you do the same thing that we were doing before. You can do that same idea. And then we use factor by grouping to solve this. So I'm going to show you with this problem, because this is going to be the answer. And I'll go ahead and type it in here. I know this is going to be the answer. But I want to show you the other method because it's definitely, I think it's a little bit, I don't know if it's necessarily easier, but it might be a little bit more clear. Let me go ahead and bring this guy back up here. Okay, so the other method that we can do is we can use the same method we were before, where we have one number that we're looking for factors that either add or subtract to the middle term. But now we have to take into account the fact that we have a coefficient on the front. So we say 3, the first term, times the last term, and we get 21. And it is going to be negative 21. So we want to look at the factors for 21, and we have 1 and 21, or 3 and 7. Okay, so these are our only factors. There's not too many here to look at. We want to find the one that brings us to 20. And because it's negative 21, I know it's going to be 1 negative and 1 positive. So they are going to subtract to 20. Okay, well that's got to be these guys here, right? So what I'm going to do is I'm going to break 20 apart. So 3z squared stays 3z squared for now, but instead of writing 20, I'm actually going to have two pieces here like this. And then minus 7 will go on the end. So instead of 20, I'm going to write plus 21z squared minus z squared, which is just 1z, right? So 21 minus 1, that gives me 20. So I just broke this guy apart here. That's all I'm doing, into its two pieces. And 21 times 1 gives me, it doesn't give me the 7 here, but it gives me the 3 and the 7 combined. So it's a little bit different because we have that coefficient on the front. But it will work out in the end here, and we're going to group these. So we're going to factor by grouping now. That's when we have 4 or more terms. We need at least 4 terms to do this. And we're going to go, I'm going to group these guys, and I'm going to group these guys like this. So now I need to figure out what is my greatest common factor here. So 3 can divide into both 3 and 21. And then z squared, or z, well, I can only take one z because that's all this one has to give. So I'm going to divide 3z squared by 3z. And I get 3's canceling. Z's almost cancel, but it's 2 minus 1, so I end up with 1 left over. Plus 21 divided by 3 is 7. And z divided by z is, those two cancel out. So here's my first one. Now I'm going to do my second one. So I have negative z and negative 7. Well, I can't cancel anything out there, but remember I want this to match, and I can already see that they're opposites. So I'm going to take the negative out. I'm going to kind of factor that -1 out. So if I divide -1 away from -z, I end up with positive z. If I divide it out of -7, then I end up with +7. So now, just like we wanted, we have matching factors again here, z plus 7. So that's exactly what we're looking for when we're factoring by grouping. So now that's going to be one of my factors. And then I have 3z, so if I factor this guy away, I have 3z. And if I factor this guy away, I have -1. Remember that there's a 1 there, we just don't have it written. So if you notice, I have the exact same thing here. It's just two methods to do the same thing. I think this one actually might be a little bit easier just to make sure you get the correct numbers. The other one can be a little bit difficult, especially when we start getting numbers that have quite a few more options. 3 and 7 don't have very many options. It's 1 and 3 and it's 1 and 7. But if we have a composite number where there's a whole bunch of different options to choose from, that becomes much more difficult, that first method I showed you. So I think I'm going to go ahead and keep showing you this one, because I think this one's a little bit easier to keep moving forward on. But there is that other option if you wanted to kind of go back and look at it and try to use that one on the future problems here. All right, so I'm going to erase this guy. Okay. Oh, and I forgot to click continue. All right, so now we have 5z squared minus 27z minus 18. Okay, so we're going to do that same thing that we did on the last one. We're going to have 5 and 18. So 5 times 18. And before you do this, you do want to make sure that nothing can divide away from all of them. Well, since this is 5, this doesn't end in a 5 or 0, this doesn't end in a 5 or 0. Can't divide anything away from all three. So we're going to do 5 times 18, and that's going to be 90. It is going to be -90 because it was -18. So we have 1 and 90, we have 2 and 45, we have 3 and 30. 4, let's see, I don't think 4 actually goes into 90. Nope, not evenly. But 5 can go in evenly. Let's see, we have 5 divided by, that's 18. Oh, yeah, of course, 5 and 18. I just did that one. 6 can go in. I know that because 2 and 3 can both go in. So I know it can actually divide by 6. It's another one of our little tricks there. I don't think we can divide by 7 on this one. Nope. And 8 does not go in. 9 does go in because that's 10 times. And that's as close as we can get. The next one would be 10, and 9, we don't have to repeat those. So because it's a -90, I know it's going to be 1 positive and 1 negative. And we're going to be subtracting to get 27. So we just want to look through and see which ones would subtract to get me 27. Well, it's going to be 3 and 30. So I'm going to write this out, and I'm going to go 5z squared, and I'm going to have plus a number, minus 18, and I'm going to break 27 apart into these two pieces. So I'm going to have 30z and 3z. Now I need to make sure one needs to be positive and one needs to be negative. I want -27, so that tells me that the big one should be negative and the smaller one should be positive. So I just need to make sure that I include that negative. Okay, so now I'm going to go ahead and group these guys like this. So I can divide 5 away from both 5 and 30, and then I can divide 1z away. So now if I do 5z squared divided by 5z, 5's cancel, and the z's, it's 2 minus 1, so I'm left with 1z. Minus, instead of doing plus negative, I'm just going to go ahead and say minus. 30 divided by 5 is 6. Z divided by c cancels. Plus, now I can divide 3 away from both of these. I can't divide z away because they don't both have z. 3z divided by 3, the 3's cancel, so z is left over. -18 divided by 3 is going to be -6. So we have our matching piece here, right? We can see that, z minus 6. So now I can write z minus 6 And if I factor away z minus 6 from this first one, I'm left with 5z. And if I factor z minus 6 away from that second one, I'm left with plus 3. So there we go. That is our factored form. So I think, because I've kind of struggled with the other method with students before, and it's just one of those things that it took me a while to break my habit on that one, because it was the way I learned to do it, and I learned to kind of figure that out and how to combine them. But this is quite a bit easier as far as matching them up, instead of trying to figure out which terms do I have to multiply, because this is quite a few terms for 90, but 5 and 18, even if I tried to do it the other way, I'd have 5, that's 1 and 5, so that's my only option there. But for 18, I'd have 1 and 18, I'd have 2 and 9, I'd have 3 and 6. So now I have to figure out not only which term am I using for 18, but how am I multiplying them? Because I have to multiply 5 by a number. Well, I know because I just solved this, it's going to be 5 and 3, right? So it's this one, 3 and 6. But I'd have to make sure I'm multiplying 5 and 3 to get 15, 6 and 1 to get 6. It's a very different method as far as working this out. So we just want to make sure that we're using the method that kind of makes the most sense. And I think this one definitely helps you move forward a little easier. It all depends on the one you learned, though, I think. Okay. So enough of the theoretical part there. We're going to keep moving forward. We're going to keep solving some pieces here. Well, we're not solving anything. We're just factoring things. Sorry, I said solving, but we haven't had an equal sign quite yet on this equation, or for any of these expressions. I'm just mixing up my words like crazy here. Okay, so before you start factoring, make sure there's nothing that can divide away from all of them. So this guy can only divide by 3 and 5. Well, 29 can't divide by either 3 or 5 or anything. It's a prime number. So we're good to go. We can start factoring. So remember, we need to take into account the fact that there's a coefficient, and we go 15 times 12, and we get 180. And it's going to be positive 180. Okay? That doesn't actually mean that they're both positive. It actually means they're both negative, because I can see a negative sign in the middle here. Okay? So we have 1 and 180. We have 2 and 90. We have 3 and, let's see, that would be 60. So we're still not close. We want them to add together to get to 29. So we still have quite a ways to go here. Divided by 4. Let's see. Nope, that still wouldn't work. Divided by 5. So this one's got a lot of factors. We're getting a little closer there. So let's see, divided by 6. Let's see, what is this? Divided by 6, we get 30. So 6 and 30. I don't think this guy divides by 7, if I remember correctly. Nope. But it does divide by 8, I think. Nope, not evenly. Let's see, it does divide by 9. I can tell because 1 plus 8 is 9. So that whole thing will divide by 9. So 9 and 20. Ooh, I found it. I can keep going if I want to list all the factors. But as soon as I find one that adds up to what I'm looking for or subtracts to what I'm looking for, I can stop. So now I'm going to write this out. Plus and plus 12. So I'm breaking 29 apart. And it's going to be two negatives, because two negatives make a positive. But remember, there's a negative in the middle. So I know they're both going to be negative. So it's going to be negative 9x and negative 20x. So now I'm going to factor, or not factor, I'm going to group them and then factor them. So what can divide away from both 5 and 9? Well, that's going to be 3. And then x and x. So we have x squared and x, so the most I can take is 1x. So I'm going to go ahead and start dividing. 15, x squared divided by 3x, so that's going to be 5. X squared divided by x is x. And then I have negative 9, so I'm going to say minus. Negative 9 divided by 3 is negative 3. X divided by x cancels out. All right, now on this one, it's going to be negative 20, remember. And I want it to end up being a positive here. So that kind of tells me I'm going to divide away a negative number. just to make sure that I end up with that positive by my x, and this guy should be negative. I want it to match this term, so I'm kind of forcing it a little bit there. So I'm going to divide away negative. Let's see, what's the greatest common factor between 20 and 12? Well, that would be 4. And then I can't take an x out because this is the only x in there. This one doesn't have any x's to divide away. So negative 20x divided by negative 4 is positive 5x. 12 divided by negative 4 is negative 3. So look at that. We have our matching terms here. So that's one of my factors. And if I factor that away from the first one here, I have 3x left over. And if I factor it away from the second term, I have negative 4 left over. So there we go. I have factored that guy. And we have 3x minus 4 and 5x minus 3. Check. Okay, a couple more of these guys. All right, negative 5w squared minus 12w plus 9. And one thing on this one, since there's a negative in the front, and I'm going to click on example because I believe what they want us to do, they're going to want us to deal with that negative first. So just like they're showing here, they're taking the negative out. They're going to divide everything by negative 1 because we don't want that first coefficient to be negative. That definitely complicates things if we don't deal with it. So we want to take that negative 1 out. And by that, I mean we're factoring it out first. So we're just dividing everything by negative 1. It's just going to flip all of the signs here. So positive 12 and negative 9. Excuse me. All right. So now what we want to do is that same idea we've been doing. So I have 5 times negative 9, and I get negative 45. And we're going to go through the factors. 1 and 45. We can't do 2. I can do 3. And I know that right away because 4 plus 5 equals 9. 9 divides by 3, so 45 divides by 3. It's one of those kind of weird 9 and 3 tricks. That works for both of them. 4 does not go in here because it's not even. 5 can go in there. We just did that, right? It's 9. 6 does not go in because it's 2 and 3 both have to go in for 6. This is not one of our 7s. So that would be 42 or 49, so that won't work. 8 does not go in because, again, this is not even. And we're back to 9. So here are all our factors. And I could have definitely stopped as soon as I found one. Since it's negative 45, I'm going to subtract to 12. So that would have been 3 and 15. And I could have very well stopped at 3 and 15 and said, oh, okay, I found my factors. There really shouldn't be more than one factor that works on this one. There's only one set that add up correctly. So now I have negative 5w squared plus a number minus 9. So I'm going to break that 12 apart. Remember, one's positive and one's negative, and I want a positive 15 or positive 12. So 15 should be my positive term because it's bigger. And then I should subtract 3. All right, let's go ahead and we're going to kind of group these again. I know there's already parentheses here, but we're grouping again here. So the negative stays out front. I'm going to use brackets for, well, yeah, I'm going to go ahead and use brackets out front just so that I can see that for a minute, and then we'll take the brackets away. So 5w squared and 15w. Well, I can divide 5 away from both of those. W squared and w, I can divide at least one w away. So if I start dividing 5w squared by 5w, then I'm left with 1w because the 5's cancel. 15w divided by 5w, well, that's plus 3 because the 15 divided by 5 is 3, and w, those cancel. Plus, I'm actually going to undo the plus because since they're both minus, I know I'm going to want to divide a negative away. So negative 3 can divide into both of these pieces, and I can't take a w. So I'm going to go negative 3, w divided by negative 3, well, that's positive w. Negative 9 divided by negative 3, that's positive 3. And I'll put the brackets back around here. So we have our matching terms. That's one of our factors. And then if I factor that away from here, I have 5w. If I factor away from the second one, I have -3. And I need to make sure I put that negative on the front, otherwise that doesn't quite work correctly. So make sure that you keep that negative on the front to show that you factored out a -1. 5w minus 3 and w plus 3. All right. One more, and we are all done with this one. All right, so 4x squared minus 11x equals 3. All right, so in order for us to solve these problems, so all we've been doing is factoring up to this point, but now it's saying solve for x. So we need it to equal 0 in order to solve this. You can also do something completing the square. That's another one we are able to do. I'm pretty sure we're going to learn that in a future lesson, although we're not quite learning that yet. So I believe they want us to factor it just like we normally would. I don't believe they want us to do completing the square. No, they do not want us to complete the square yet. They want us to have a regular factored form, just like we've been doing here, which completing the square would also give us that. But in this case, what we're going to do is we're going to take this 3 and we're going to move it over to this side. We're going to have 4x squared minus 11x minus 3 equals 0, because these guys cancel out. So now we're going to do the same thing we've been doing. 4 times 3 is -12. This negative tells me I'm going to have one positive, one negative, and I'm going to subtract to get 11. So 1 and 12. Well, that's my terms, because my next one would be 2 and 6. That doesn't work. 3 and 4, that also doesn't work. So this is the only ones that will work to subtract to get down to 11. So I'm going to have 4x squared plus a number minus 3. And again, we're breaking this apart, so it's going to be -11, which tells me the bigger term needs to be a negative. So -12, positive 1x, or just x. All right, let's go ahead and group these guys like this. Okay, so we can divide 4 away from both of these numbers, because 4 and 12 both divide by 4, and I can take at least an x out there. So 4x squared divided by 4x, that's just x, minus 12x divided by 4x, well, that's going to be -3. So, because the 12 divided by 4 is 3, x divided by x cancels out. Plus x minus 3, and I don't have to do anything with this one. There's nothing to factor out, and it in fact already matches. So that is my factor there. And then if I factor it away from the first one here, I have 4x. If I factor away from the second one, I'm left with just plus. Remember, that means +1. Now I'm not done yet. They don't want me to type this equation in. What they want me to say is, what is x equal? So this is 0. And remember, once we get to this point, now we set both equal to 0 and we solve them like this. So we actually get to solve when it equals 0. So we go -1, -1, 4x, the 1's cancel, equals -1. I'm going to divide by 4. And I know I'm going a little fast on this one. I've gone a little slower on how to solve equations in previous sections, so you can always go back to those if you kind of need a tutorial on how to go through and solve a multi-step equation. So I'm going a little fast on this one, I know. -1 divided by 4 is -1/4. So that is the answer there on that one. And then on this one, all we have to do is add 3 to both sides to get x by itself. 3 minus 3 cancels, and we end up with +3. So these are my two solutions. These are where it crosses the x-axis. And with comma, 3. So I just have to separate them out with a comma there. And I'm going to click check, and we are good to go.